In this video, we're going to do section 4.4, addition and subtraction of polynomials. So topic 1 is identify polynomials. A polynomial is an expression involving constants, variables with natural number or non-negative integer exponents such as 1, 2, and 3, and the four basic operations of addition, subtraction, multiplication, and division, and no variables in the denominators. So it can have variables, and it should have variables, just not in the denominator. Alright, so the product of a polynomial is always a polynomial. However, the quotient, or the answer to the division problem of two polynomials, is not necessarily a polynomial. So find the terms and coefficients. So each term is sort of separated by an addition or a subtraction sign in a polynomial. So we have three terms here. So the terms are a 3x, a 2, and a negative 7y. Remember this at all times. The sign in front of the coefficient, or the number in front of the variable, is going to keep the sign. So if it's a minus 7y, it's a negative 7y for the term. Alright, now the coefficients again are just the numbers here, so it is 3, 2, and negative 7. Alright, let's look at example B. We're going to do the same thing again. We're going to simply list the terms. And we have 1, 2, 3 terms. Negative 2m squared n, 5n squared, and 4nm. And the coefficients are going to be negative 2, 5, and 4. Kaboom! Alright. Now, hopefully this is going well for you so far. As you know, when we start out, sometimes it tends to be a little bit easier, but this will stay as easy as I can make it. Alright, so see, three terms again, 3a to the third, or 3a cubed, b squared, and negative 8. And then we have coefficients. Now, this one might be a little bit tricky, but not too bad. We have a 3, but since there wasn't a number in front of the b squared, this coefficient is just 1, and then we have a negative 8. Kaboom. Alright, hopefully there are no concerns about that, but if there are, please feel free to email me and ask or bring your question to class. But we're going to go on a little bit more in depth into polynomials and polynomial vocabulary right now. So here are some examples of polynomials on this side of this chart, and then some that are non-polynomials on this side of the chart. So you cannot have square roots in polynomials, you cannot have variables in the denominators, and you cannot have negative exponents. Alright, so any of these three things is bad, bad, bad. Alright, so now let's look at example 2. So which of these are not polynomials? Well, if I look at them carefully, I see B is not, because it has a negative exponent. And I know that D is not, because it has a fraction as an exponent. And although I specifically didn't say that you couldn't have that, I did say that the exponents had to be natural numbers. So the exponents must be natural numbers, meaning 1, 2, 3, etc. Alright, so this is not a polynomial because it has a fractional or a non integer exponent. Alright, that means that A must be a polynomial because it doesn't break any of our rules for not being a polynomial. And 12 is a polynomial as well, even though it's just a constant or a number by itself. Alright, so hopefully that is all okay with everyone. But there are just some additional examples of polynomials and non-polynomials there. Polynomial vocabulary can get a little bit tricky. We talked about terms just now. Alright, so this one would have 3 terms. We talked about numerical coefficient just being the number in front of the variables. And this is a polynomial. This is a polynomial. Oh, actually, this is not supposed to be a polynomial. It's just supposed to have a minus here, not equal. Sorry about that. Now, a monomial is also a polynomial. So make sure that you don't think that monomials are not polynomials. They are. It just has more than one name because it's a special polynomial, which is one term. The same thing for a binomial. It's a special polynomial, but with 2 terms. And same thing for a trinomial. It's just a special polynomial, but with 1, 2, 3 terms. The degree of a term is something that some people get a little bit confused about sometimes. You see here the degree is actually the sum of the exponents. So in this case, if you had 6x squared, y to the third, you have 2 plus 3 is 5. Degree of 2x is just 1 because the exponent on the x is 1. And if there aren't any x's at all and you have a constant like 5, that's the same as saying 5x to the 0. Since x to the 0 is just 1 and 5 times 1 is still 5, so that means that the exponent would be 0 there, and the degree is 0. Alright, and if you have the degree of a polynomial in one variable, it's a degree of the highest degree term, so 4x to the third is degree 3, 2x is degree 1, so we pick the highest of those. And it ends up being 3. Alright, I mean, I know this isn't very exciting, but I know who is excited. All of you are. Okay, great. Similar terms or like terms. These are terms that have the same variables and exponents. I know that we talked about combining like terms when we were solving equations in the past, so I think that you do know what like terms are already. And there are also several ways to classify polynomials. We talked about this by classifying by number of terms, like 1, 2, 3 terms, or monomial, binomial, trinomial, but you can also classify them by their degree. And so anything with degree 1 is linear, degree 2 is quadratic, degree 3 is cubic, degree 4, I didn't put this down because it's not as common of a name, but quartic. And then if it's degree 0, I mentioned this a little bit earlier when I had that example that was 12, it's just a constant. And if it is 0, it's just undefined. Alright, that's just an undefined polynomial because it just 0, it doesn't really exist. Alright. Well, the 0 doesn't, but remember that this is something that's a very tricky thing to deal with because of the fact that we already know that 0 to 0 is undefined, if you guys remember about that. Alright, so keep that in mind. I mean, this is the basis of where this degree undefined comes from. I don't want anyone to really get upset about that. Alright, example 3. Classify the expression as a monomial, binomial, trinomial, or polynomial, meaning none of the above, and give the degree. Alright, here we go. This is a trinomial, 3 terms, and the degree is 2 because the highest power term is 2. B is a trinomial, which is, oh, and I cannot spell trinomial tonight. What is wrong with me? Alright. Excuse me, and degree is 12 because the highest power term is 12. C, one term, monomial. So the degree here is just 1 because this is like 4x to the first power. D is a monomial, meaning just one term, or you could say it's a constant if you wanted to. And the degree is actually 0. So we talked about that before as well. E, two terms, so binomial. And the degree is 3. F, 1, 2, 3 terms, so a trinomial with degree highest power is 2. And H, 2 terms, so binomial, and degree is 1 because the highest power terms were both 1. Alright, even though one variable was x and one variable was y, each term had degree 1, so the highest power was 1. And then I, this is a monomial, or one term, and then the degree, because the a and the b are being multiplied here, we have to add their exponents together to find the degree, and it's degree 2. I hope that all of you are getting very excited about this. I can tell that you truly are. Alright, thank you. Now let's look at the next section here. J. This is sort of a repeat again. So 2 terms, binomial, and the highest power is 2, so the degree is 2. K. This is a binomial. This one is a little bit trickier because we have a degree of 2 here, but we also have a degree of 2 here because we have to add the exponents on the x and the y together. So the highest was still 2. Alright, the same thing for L. We have 3 terms, trinomial, and the degree is 7. There's the highest power. And then M, we have a monomial, and the degree is 0 for a monomial, sorry, for a for a constant. Not all monomials have degree 0, just this particular one. Alright, oh, write the polynomial in descending order and give the degree. So sometimes we don't want the exponents to be out of order. We want them to be descending or from highest to lowest. So I'm just going to rewrite 3x to the 5th plus x to the 3rd plus 3x to the 4th is 3x to the 5th plus 3x to the 4th plus x to the 3rd. So it goes 5, 4, 3. Simple as that. And then we can more easily tell that the degree is 5. Maybe not too much more easily in this case, but in a very long polynomial, sometimes it helps to make sure that the highest power term or the highest degree term is the first one. P, what is the degree of 8x squared y to the 3rd plus 7x to the 4th minus 17y to the 3rd minus 2? We have 1, 2, 3, 4 terms, and let's find the degree of each of these. And then we pick the highest of all of these numbers, 5, 4, 3, and 0, and it is 5. Alright, that one may have been the trickiest one just because you had to remember to add the 2 and the 3 on these two exponents because they were in the same term, and then pick the highest one overall. But I know that all of you can do this. Alright, let's look at the example 4 here. Identify which of the following are polynomials. If not, state its degree. Well, wait a second. Didn't we just have that? Okay, that was sort of like what we did before, but now it's asking us to also state the degree. Alright, so we know this is not a polynomial. We already did that, and we already knew this one was not a polynomial, if you remember these same examples from a few pages ago. But these ones, A and C, we didn't find the degree before, so why don't we find the degree now? So we have to find the degree of each term again. So the degree of this term is 3, this one is 2 plus 2 is 4, and this one is 1 plus 4 is 5, so the degree is the highest one of 3, 4, or 5, which is 5. And then 12 is a monomial constant, and so the degree is actually 0. Kaboom! Alright, the excitement seems to be real. I can feel it. Let's move on to example 2, which is going to be adding polynomials. So, add. To add polynomials, combine the like terms of the polynomial. So, we have 2x minus 7 plus 4x plus 9. Here's a like term, and here's a like term, so why don't we add those together? First, 2x plus 4x is just 6x. And then we have a minus 7 plus 9, so minus 7 plus 9 is actually a positive 2. Kaboom! It's real. Alright, so let's look at B. So let's look for the highest power term first, and I only see one x cubed term, so 9x cubed. Then I'm going to look for the squared term, because again I want to try to write this in descending order. So I have x squared minus 2x squared is a negative 1x squared or negative x squared. I guess I could have brought that 9x squared or 9x to the third down for you guys. And now let's move on to the x term. So we have a minus 5x plus 4x. So that's a minus 1x or minus x. And then finally, we have plus 10 minus 15, which is minus 5. Kaboom, done. It's real. Alright, so I know some of you hate math, but I have great news. This video isn't over yet. Let's move on to the next page. 5a squared b plus ab plus 2b plus 7a squared b minus 3ab minus b. So let's look for the like terms. So I see some terms that have a squared b in them. So 5a squared b plus 7a squared b will be the 12a squared b, because the 5 plus the 7 is 12. Then I look for my ab terms, which are next. So plus ab minus 3ab, that's like 1ab, so 1 minus 3 is negative 2. And then I have the plus 2b minus b, that is just a positive 1b. I hope the struggle is not too real for most of you. This seems to be pretty exciting. Again, feel free to email me or bring questions to class. I want you to understand all of this. Also, make sure that you're practicing as much as possible. Now, we're going to also try another method of just adding polynomials and columns. Some people will actually like this a little bit better. So if I'm adding 6x squared minus 3x plus 3 and negative 3x squared minus x plus 5, I can just actually write them underneath of each other. And then go 6 minus 3 is 3, minus 3 minus 1 is minus 4, and 3 plus 5, 8. Kaboom, it's done. Alright, without finding the like terms being difficult, I just write them underneath each other. So if I have 4x to the third plus 3x minus 4, oops, and I'm going to make this a little bit more obvious why some of you might like adding in columns. Alright, then I have 4x squared. I don't see a 4x squared in the first polynomial, so I'm just going to write it down here where the x squared would have normally been. And then the minus 5x minus 7. And then add this together. So bring this down, 4x to the third plus 4x squared, then 3 minus 5, negative 2, and then negative 4 minus 7 is negative 11. It's done! Alright, so make sure that when you're adding in columns that you are just lining the like terms up and then add. Alright, I'm really enjoying this. So let's move on to the next page, subtract. The one thing that you need to remember about subtracting polynomials is that you're going to have to remember to distribute. If you don't remember to distribute, it's over for you. That's all I have to say. It is over. Alright, so make sure that you do remember to distribute and switch all of the signs in the second set of parentheses. So 8m plus 3 minus 2m plus 4 becomes 8m plus 3 minus 2m minus 4. Then combine the like terms just like before. So 8m minus 2m, and that would give me my 6m. And then I have plus 3 minus 4. That is a minus 1. It's over. 6m minus 1. Again, in B, we have to remember when we're subtracting to distribute the sign here. So we have 3p squared minus 4p. That will make this plus 2p squared minus 14p plus 1. So combine the like terms, 3p squared plus 2p squared. That will be, what is that going to be? I don't know. 5p squared. And then, let's see, what do we have next? A minus 4p, and then a minus 14p. So minus 4p minus 14p is minus 18p. And then plus 1 at the end, so plus 1. Hopefully this doesn't seem like it's a whole lot of extra for you. I know that, again, the struggle can be very, very real, but hopefully it's not real for you. Alright, so now let's look at, I know you don't like ones like D, but I just want to remind you on D, since I'm seeing it here, that when it says subtract something from something, that you have to actually reverse the order. So it would mean that this comes first, and then this is what is being subtracted from it. Alright, so I know that all of you can easily remember how to do this. I know that it can seem like it's overwhelming, but life is just sometimes overwhelming sometimes. But, you know, math is just one struggle on your journey in life. So please feel free to, again, try all these You Try It problems and to email me and ask questions. But I really, again, just want you to get a full understanding, or as good of an understanding as possible. Alright, let's look at the next page. We're going to subtract using columns now. So subtract 4k squared plus 3 from 8k to the third minus 3k squared plus k minus 5. So we're subtracting this from this, so I'm going to write the 4k squared plus 3 under it, and that's what we're subtracting. Now remember, we're subtracting this whole thing, so we actually have to still remember to distribute, because if we don't remember to distribute, we're sunk. That's all I can say. Alright, so that becomes a minus, and this becomes a minus. Then we just add them together. 8k to the third minus 7k squared plus k plus 2. Some of you will automatically say that you like this a little bit better, but the fact of the matter is that some of you will also forget excuse me, to distribute the negative sign. So I don't know. It is a little bit tricky to remember all of these steps, because there are definitely a lot of steps to remember. There's more steps to remember than my grandma's chocolate chip recipe. Alright, so I don't know what to tell you here. Just try to remember it all. So now, if we remember to distribute the negative sign, we have 2c to the third plus c squared plus c plus 10. And as always, coming up, there's going to be some problems for you to try on your own. I do encourage you to do that. But that is the end of section 4.4. I truly hope that all of you enjoyed this.